ओके जी, स्टार्टिंग विद दैट, हमारे पास जो मेन आइडियाज जो हम लोगों ने लेके चलना है, द इशू ऑफ विनेगर, ठीक है। हम लोग लेक्चर नंबर 1 है, एंड इन दैट लेक्चर व्हाट वी हैव टू डिस्कस बेसिकली, जो हम लोग बात कर रहे थे कल के, मैंने आप लोगों को स्टार्ट से लेके चलना है, और फिर हम लोग इससे आगे जब चीजें डिस्कशन में लेके जाएंगे तो वी हैव टू फिगर इट आउट कि व्हाट आर द प्रॉब्लम्स एंड वेयर वी हैव टू। सो पहला जो मैंने टॉपिक सेलेक्ट किया ना आप लोगों के लिए, दैट इज वर्क एज अ फिजिस्ट, वर्किंग एज अ फिजिस्ट। यूनिट नंबर 1 में मैं इसको डालूंगा, बट द मेन प्रॉब्लम इज कि इट इज नॉट द पार्ट ऑफ द मोशन, राइट? इट इज अ बेसिक थिंग। तो मैंने कोशिश ये की है कि इन द फर्स्ट वीक वी हैव टू मेक अ कंप्लीट बेस, एंड देन वी विल मूव टू द नेक्स्ट एरिया. So in that regard, I have just selected few points for the discussion, discussion of today's lesson, inshallah. And those points are, when we talk about the working as a physicist, so we have to figure out all these areas. We have to work on all these areas. And better see, all these areas means, first of all, we have to now what is to be measured, how to measure, और फिर हमारा जो बेसिक कॉन्सेप्ट चलता है कि when there is a quantity which is to be measured, so what do we call it, why it is a base quantity, why it is a derived quantity, then what are the standards of measurements of all these quantities, and then when we talk about the measured quantities, how to represent them. हमें कुछ prefixes की भी जरूरत पड़ती है, and once we are having the prefixes, then those prefixes are basically dealing with the measurement. So basic discussion में all these areas are correlated with each other. For example, if I have linked the standards of physics, standard units of physics in base quantities, okay, and derived quantities, so you people must know that these base and derived quantities are not entirely separate. They are linked with the SI base units of base quantities and derived quantities, and then we will discuss about them in this. जब आपकी physical quantities बन जाती हैं, so then we talk about this all, that this is basically the measurement. Okay, so measurements are actually those techniques in which we take the measurements of all these physical quantities. What do we have? And measuring techniques में आपके पास क्या आ जाता है? We must know the prefixes, the estimation, and some errors and uncertainties. So ये सारा criteria आपके पास है, which I will discuss one by one, inshallah. ठीक है? Okay जी. So starting with the standard of units in the physics. So anybody can guide me about that. Anybody can guide me. What are basically the standard of units in the physics? Yes. Any of you? No idea. देखो, standard units used in physics means के, for example, first of all, I will talk about the quantity here. What does it mean by a quantity? Umer, can you tell me? Yes. Umer, do you hear me?
Sir, it can be time acceleration like this.
Okay. Actually, quantity means anything which can be measured, right? So whatever you are measuring, that is called your physical quantity. Okay. So that means we have a lot of things which can be measured in our daily life. For example, your speed. For example, your temperature. Okay. What else? There are so many moment, momentum. Yes. Force. Yeah. Acceleration. Then uh, so
Amount
many.
of
I will,
substance.
yeah, I will give you a list of these physical quantities. But there are some things which cannot be measured. Like we call them, they are non-measurables. Like those non-measurables are just like your emotions, right? So we call them that these are not measurable things. like that is truthfulness. ठीक है, कोई आदमी कितना सच बोल रहा है, जैसे उमर कितना सच बोल रहा है कि मुझे फिजिक्स कितनी अच्छी लगती है, सो दैट इज अनमेयरेबल. ठीक है, then your emotions, right, your liking, disliking, they all are actually those physical quantities which are not, and these are quantities, sorry, or you can say these are the things which cannot be measured. So we have to figure out these areas कि हमारा एरिया क्या होगा. We have to discuss the physics, that is why we will talk about the physical quantities. So once we have deal with the quantities, I will divide the quantities into two categories. One, I told you that these are the base quantities, right? The base quantities are those quantities basically which are independently measured, right? They do not depend upon any other, so they are independently measured, right? They are independently measured, or you can say they do not depend upon any other physical quantity when you are going to estimate them, or when you are going to figure out them. For example, I can say that there are seven, just simple game, that there are seven physical quantities, and you can list them all. And listing them all is quite simple to now, that these physical quantities are basically, uh, yeah, I will write all those on the next slide. Just one thing I want to add here, that all these quantities are taking part to figure out the new physical quantities. Yani, these are the base quantities and they will give us the derived quantities. Okay, so I will talk about these all in details, और इससे फिर हमारा आगे टॉपिक चलेगा. Okay, so base quantities are seven in number. Can anybody tell me about those seven base quantities? I mean, can you enlist those seven quantities? Anyone?
Length,
Very good.
mass, time, temperature,
temperature,
Well
electric
done.
current,
Very good.
intensity
Temperature.
of light as well.
Well done. So these are length, mass, time, temperature. Then we have electric current, amount of substance is one of them. Okay, amount of substance. And the last one is intensity of light. Intensity of light. So these all are basically the base physical quantities, and we have to recall their symbols, that length is usually represented by L, mass is represented by small m or capital M, but it is represented by small m. Time is represented by small t usually. When we represent the time with capital T, it is your time period. Then temperature, it is represented by either theta or T. I will tell you about these two representations, that why are they different. Then electrical current, that is represented by I, and then amount of substance is represented by N. You have learned about that in detail in chemistry. And then intensity of the light is represented by L, luminous intensity. It is also called luminous intensity. So once we have all these physical quantities, they are the basic quantities, they are the base quantities. There is no other quantity which is other than these, which is base quantity. So here I will talk about that. For any physical quantity, we have to know about the unit, right? There are several units, those units are basically the standards of measurement. Okay, they are the standards of measurement. Let's say if I say that the length is measured in several physical quantities. So, can you tell me what are the common standards of measurement of length? Common
Meter,
standards which are common in your daily life. Meter, very good. What else? Kilometer,
kilometers,
yard. हम कहते हैं ना कि this is not a yardstick. So that is a yard. Then we have foot. Then we have centimeter. Then we have basically meter. Sorry, millimeter. Whatever that is. There are so many. Right. There are so other physical quantities which are sorry some other units which are common in our daily life. But out of these, there are several which are considered as the standard quantities, right? They all are not international standard quantities. So, those physical quantities which are basically internationally recognized, they are called SI units. Actually, there was a best created around the world that okay, this physical we have to measure this physical quantity in this unit, etc., etc. So in 1960 in Paris, there was a conference of international uh, uh, I think so. Weight and measurements, International Conference of Weight and Measurements. I think so. I'm not quite sure about this letter. International Conference or International Committee of Weight and Measurement. They have decided that there would be several systems, and out of those several systems, one is considered as the international units or standard of international units, and that is called your SI units. Okay, so here the SI unit of your length is meter. In this way, I will let you know that there are several physical quantities, and out of those several physical quantities, we have a lot of units which we have to take care or which we have to consider. For example, I will write all SI base units. If you just consider them, that SI base units of base quantities. Definitely, SI base units means that the SI base units means the SI units of base quantities. Okay, SI units of base quantities. Now, moving on, for every base quantity in length, mass, time, temperature, current, and then amount of substance, and then electric field intensity. I will write them. Yeah, if you don't get confused that I can make it with small length, small l, it's length and it is made into meter. Okay, you have to recall the symbol as well as units symbol, name and symbol. Then mass, SI base unit of mass is kilogram. Okay, and we mm, represent it by kg. Then for time, we have second as a SI unit, and we represent it with S, not SEC or anything else. For temperature, it is Kelvin. There are some other units as well, but Kelvin is the standard unit, so it is represented by K. And for current, it is ampere. Okay, ampere, and it is represented by capital A. In the same way, for amount of substance, it is represented by mole, MOLE, and its abbreviation or its symbol is MOL dot. And then the intensity unit is candela. Okay, and it is represented by CD. So actually, I have written these all in two different classifications. If you see, these are not that much common. They're not used in the derivation of the rest of the physical quantities. But these all, what I have mentioned here, these all physical quantities, yani these five, they are the physical quantities which are very common and they are used to derive the in physical quantities of the next generation or next stage physical quantities. Right? Is there any confusion in this one until this slide?
No, sir.
Okay. Right after that, we will talk about the derived quantities. Right? What do we have to discuss? That there are some derived quantities as well. So actually जब हम लोग derived quantities कर लेंगे ना, then you people will feel कि oh now questions are moving towards A level. Okay, so all physical quantities other than those seven, they are derived quantities, right? So you can have a list of derived quantities. For example, if I ask you that you can say starting from very small area, volume, density, speed or velocity, acceleration. Okay, then force, then work, then energy, then movement, then momentum. After that, you have pressure.
Pressure.
Very good. Then we have stress. We have strain.
Heat capacity as well.
Voltage.
Yes. Yes. Well done. Well done. Strain. We have Young's modulus.
Wavelength.
Well done. Young's modulus के बाद हम लोग चले जाते हैं yes, these are were all from your mechanics. And right after that, let's talk about in thermal. You told me heat capacity.
Yes, sir.
Yes, heat capacity. Then
Latent heat.
yes, latent heat or specific latent heat. Okay, specific latent heat. Okay, and then when we move to the next, we have the electricity. Okay, and electricity is starting with charge. Okay, then we will move to after charge we will move to the voltages. Okay, yani in voltages you have both potential difference and EMF. Okay, then you have resistance, then you have resistivity.
Decay constants as well, sir.
Sorry, which one?
Decay constants.
Decay constant. Yes, yes, very good. ये याद करवानी है मुझे सारी आखिर में. When I will reach to the nuclear, then I will write that as well. Okay, after that resistivity, we will move to the waves. In waves,
Wave
you
speed.
told me about. Sorry, दोबारा बोले बच्चे.
Wave speed.
Yes, frequency. Wave speed is okay. I have considered that as speed, so I think it would be covered over there. Then time period is considered in time. It's fine. That's why I will not write it. Wavelength is the distance. That is why it would be considered as the same as the length. Uh, yeah, that is why I'm not writing all of them because they are not derived one, right? They are actually time period is to somehow direct measurement and wavelength is to somehow direct measurement. But okay, let's write about that. Then later on we will talk कि हमें इसको करना चाहिए या नहीं. Time period, very good. Then we have wavelength. Yes. After
Sir,
that, yes,
would the gravitational field strength be included in this list
yes,
as well?
that is very good. Gravitational field strength is one of the physical quantity. I will add that over here. Very good. That means कि space छोड़ने का फायदा हुआ है. It is gravitational field strength. Gravitational field strength as well as gravitational potential and so on. Gravitational potential. Right. So these are there are so many physical quantities. I will try my best to put most of them on the screen. After the wavelength, I will move to the electricity is done. Electromagnetism. Yes, in electromagnetism we have magnetic flux. Okay, magnetic flux. Then we have magnetic flux density. Flux density. Right. Then in quantum, you will come across work function. Although it is energy, but because that is a new physical quantity, so that is why I will write it down. Work function, and then you will go to the activity in nuclear, and then you will go to the decay constant. So these are almost all physical quantities which you will use in your physics in IAS level almost. I believe so. There are uh, very few which are left over. Otherwise, we have covered almost all of them. Okay, Ji. So, in all these physical quantities, what is important? The important thing is for all of them, we are not able to recall their units, but we can derive their units. Okay, so derived units. That is very important topic for today because I will discuss all these areas inshallah that how to form a derived unit and what is the function of the derived unit. Okay, so in derived unit, what do we do? They all are coming from the base units. To express to determine the SI base unit expression of any physical quantity, we need some basic rules. Okay, and those basic rules are I'm just writing them all to express any derived unit or any yes derived quantity rather in the form of SI base unit expression. Okay, Ji? This is the topic. It's e- I mean I will require some of your feedback. In this discussion, the most important thing is the most important, for this all, that is we must now the defining formula. Right? What is the most important? The defining formula is the most important. Yani, if I tell you I am talking about the defining formula of every physical quantity, so it would not be wrong. Okay, so starting from the force, Force. How can you define force mathematically? Its defining formula is
F
that
equals
F equals
M.
to ma. Well done. So m is mass, so its SI base unit will be kg, and acceleration is meter yani velocity divided by time. That is why it would be meter per second square. So this is the first thing you have to recall, that the SI base unit of this is the SI base unit, but the SI unit of the force is Newton. So there I have written two things. This one is its SI unit. Okay. And this one is its SI base unit. This is what? SI base unit. So remember this thing, that whenever you are going to represent any physical quantity in terms of SI base unit, we must know about its fundamental defining formula. Then we will be able to, make it, uh, or to extract it, or to derive it. So for force, its derive, yani its SI base unit is kg ms minus 2. You have to recall this expression by all means. Once you will recall it, it would be very easy for you to use in the next equations, right? So is it easy to recall?
Yes, sir.
Okay. Now I will figure out different physical quantity. For example, right after that, I'm moving towards work. Okay, ji. What is work? Work is defined as W is equals to F times D. Is it clear to everyone?
Yes, sir.
Okay, so SI unit of the work is joule, but SI base unit of force is kg ms minus 2, and there is a unit for distance, it is meter. So overall, what did you get? You get kg m square s minus 2. Actually, this is the SI base unit expression for joule as well. So every type of energy, all energies, okay, basically they are extracted from work. All energy formulas, they have same SI base unit expression, and that is kg m square s minus 2. Is it clear to you?
Yes, sir.
Okay. Where clear है बच्चे?
Yes, sir.
Okay. Now I'm going to move towards uh, one more physical quantity. Then I will give chance to you people. Work के बाद आपके पास है moment. What is the formula for moment?
Force times distance.
Huh?
F times B.
F times D. Very good.
Force time
So
distance.
very good. Moment is basically F times D. So if you have same formula for the work and moment, don't you think that it would have the same SI base unit expression?
Yes, sir.
It would, sir.
Yes. So, yeah. So that is why it will be kg ms minus 2 into meter. So it will give you kg m square s minus 2. So this is basically SI base unit expression for the moment. So moment, energy, and this work, they all have the same SI base unit expression. Now I am moving to the next quantity, that is your pressure. Okay, everyone is requested to just make SI base unit expression for pressure. Then I will try it for you. Yes, yes, Fatima.
So pressure is force over area. So it will be
Okay,
kg ms minus 2 upon meter square.
Okay. If you people are not agreed, you people can have your opinion upon meter square. Good.
So SI base per unit will be kg m minus 1 s minus 2.
Yes. So all those equations, actually, the SI unit of the pressure is Pascal. So Pascal can also be written as kg m minus 1 s minus 2. So these all are the areas what we have to consider as that of your SI base unit expression. Now, I will give you some tasks right now. Uh, I will believe that you people will help me out to figure out all these areas. For example, for the stress, I will give you the formula of the stress. Stress is equals to force per unit area. Okay. Then I will go to the strain. Strain is basically change in length. That is change in length per unit original length. Yani extension divided by length. The next one is uh, Young's modulus. That Young's modulus is E is equals to stress divided by strain, or you can say stress upon strain. Okay. Okay. So these are one, two, three SI base unit expressions. Okay. One more thing. We have power. Okay. What about the power? Power is equals to energy divided by time. And there is one more physical quantity that is basically your, I have not mentioned here, that is your intensity. Okay. That is your intensity. Not intensity of light, simply intensity of wave, you can say. So that intensity will be added here. Okay. So I will just request you all to figure out all these SI based unit expressions. Okay. As a task, I think so. It would be easy for you. So intensity is defined as power divided by time. Yes, one by one, please. So who will tell me about the stress? Yes, Fatima Zahra.
So since stress is again force upon area, it will be the same as pressure. So we have kg ms minus 2 upon m2, which is kg m minus 1 s minus 2.
Okay, it is kg m s minus 2 upon meter square. So overall, we went as kg m minus 1 s minus 2. Very good. Good. Strain, Umar. What about strain? Strain is extension divided by length. Yes. Can you tell me? Umar, are you there?
Sir, I am here, but I forgot.
एक्सटेंशन का यूनिट बता दो बस सादा लफ्जों में.
Sir, meter,
Yes. Anika Umar.
meters, man.
Yes, meter. Very good. Extension is a length. So length is also length. So it has no unit. Remember this thing. So strain has no unit. Next is for Anika. Anika, can you please tell me what is what will be your opinion for stress over strain? I mean, for Young's modulus,
It it does not have any unit.
it does not have any unit. Young's modulus.
Yeah.
Okay, so it is stress divided by strain. For stress, what did you get?
For stress, we got it, but we divided by 0. So
Oh, no, 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 no. It is kg m minus 1 s minus 2 divided by no unit means 1 constant, right? So actually,
yeah.
I'm explaining. I mean, I will express that in detail. Just give me a second. For example, if I figure it out that stress, yani Young's modulus, is equals to stress upon strain. So stress is force divided by area whole divided by extension upon length. So I will express that in this way, that this is force upon area into length upon extension. So now can you figure it out that without making that zero misconception, it is kg m minus 1 s minus 2 for this f by a, and this is meter upon meter, so that all goes out. So it means you get the same SI base unit expression, and that SI base unit expression is basically this one, is it?
Yes.
So this is interesting that for strain and stress you have the same thing. Sorry, Young's modulus. For Young's modulus, okay. Okay, now moving to the uh, power. Who is left? Fatima told me, Anika told me. Where? Yes, Umar, you want to tell me about power?
No, sir, I was just gonna say that why can't we just simply write Pascal for Young modulus?
Actually, Pascal is SI unit, but not SI base unit, right?
Right, sir.
It is SI base unit. So that is why I'm telling you that once we are digging out all the SI base units, yani all the derived quantities in terms of SI base units, so we are able to now whether I mean which base quantities are involved in the formation of this quantity. Okay. Yeah. Okay, who is left? Yes, Umair. Umair, आप मुझे बताएंगे पावर का फॉर्मूला.
Sir, it's energy divided by time, or it can be work divided by time. Energy has joules and time has seconds.
Okay, so what will be the final? Yeah, it is kg. Okay, wait. For just in this way, we can make it is basically energy is work done. So it is F into D divided by T. A new formula is there. So F into distance divided by time is speed. So you can simply say it is kg ms minus 1 ms minus 2 into this is meter per second, isn't it? Am I right?
Yes.
So it would become kg m square s minus 3. So this is basically the SI base unit expression for the power.
Sir, can you explain it once more?
Sorry, can you repeat please?
Can you explain once more?
Yes. Listen, this is what I did. I just combine these two. F into D is work done, and I have divided work done with time. So F D divided by T is velocity, right? Is it clear to you?
Yes, sir.
Okay, it means that now I will put the SI base unit expression for basically work done. So work done is sorry, force. For force, it is kg s minus 2, isn't it?
Yes, I got it, sir. I got
And then
confused
for
on the
velocity,
V part, thinking if it's voltage or velocity, but now it's clear. I got it, sir.
okay, okay. Now is it clear?
Yes, sir. Thank you, sir.
Okay, good, well done. So for power, it is the same. For example, it is intensity. So I can say that intensity is equals to power is kg m square s minus 3 divided by second. So it would be what? Kg m square s minus 4. Oh, wait. I made a mistake. Sorry. Just give me a second. Okay. I will be on the other slides and then I will let you know what mistake I made. Oh my god. For intensity, actually, intensity is energy passing through a unit area per unit time. This is the definition of intensity, you know? So, if I say that it is energy divided by time into area, so it would not bad. Basically, this is basically fraction over fraction format. So fraction over fraction means energy divided by A into, okay, let me write this again for you in that format. Intensity is equals to energy over area divided by time. तो time upon 1 कर लेता हूँ मैं. So now I will make it energy upon area into 1 upon T. So that makes it that energy per unit area into time are 5 minutes. Okay. So that means that energy का unit हमने calculate कर लिया. kg m square s minus 2, and for area I did m square, and for time I did second. So overall the change will be, देखो meter square will be gone, so you will get kg s minus 3. Yes, this was a unique thing, that is why I came to now कि ये तो मैंने गलत कर दिया. Okay, the next is uh, the part of electricity. Okay, next part is the part of electricity. Here I am just going to give you a home task. आप लोगों ने एक बात याद रखनी है. I will come back to back with all these once you will submit the for I mean all the formulas. Then we will, you know, explain them, or I will explain them in detail. What is your homework? This slide number yeah, this one. This all is done. Okay, so till that point, then I have added intensity, heat capacity. Let's number these all: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 18 and 19, if you are not able to do that, no issue at all. 19, then this is 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and 33. So your homework is only 20, 21, 22, 23, 24, 25. Okay, I will send you this slides. And that is why, if you are able to just note it down: 20, 21, 22, 23, 24, 25. So you people will try this at home and
Yes.
send it to me. Okay? कर लोगे? I
Yes.
will discuss them all in the next class. कि basically uh, what we learned, basic ये काम homework देने का सिर्फ एक ही objective है, that whether what did we learn, and whatever we learned, is it clear to you or not. Okay, कल क्योंकि इंशाल्लाह I will move towards the measurements, prefixes and estimation, and then we will talk about the errors. That error is a big topic. तो बस ये छोटा छोटा करके मैं आप लोगों को लेके जा रहा हूँ. I hope that this would be very clear to you. Any confusion, any question you want to ask me?
No, sir.
Okay, okay, see you then inshallah.